Hi everyone, my name is Ishan from Pynest. Today I'd like to share with you what I think is a very common case study of data assembly and merging. Imagine you have a market analytics service with dozens of integrations, which provides tons of data through different APIs. The problem is this data is scattered, but your clients need all at once. In business, data is key to success. The more you gather and analyze, the better you understand your customers and processes. Companies like Amazon and Patrick's combine data from all their channels to offer personalized experience and improve efficiency. Systems like Google and Adobe help companies collect and analyze data from various sources. Data omnichannel allows you to gather information from online stores, social networks, mobile apps, and offline sales points into a single whole, tracking an entire customer's journey map, CJM. Want to know how big companies do this and how you can too? Stay with us and I'll share all the secrets. Let's imagine this situation. We have an application service for end-to-end marketing analytics with a large number of integrations. We need to get the maximum amount of integrations for each integration to provide it to our clients. Of course, we consider the connection to the service. It can be a REST connection, sockets, some external message brokers, anything that allows us to get the information. All sounds cool, but usually there are situations when the integration provides dozens of tops on a port at a time, or to get all the information you need to make several REST requests with different parameters. The case I want to share is not an exception. We have an integration with a large number of parameters, and the customer meets all of them, but it is impossible to get them in one query, because rendering of some columns is impossible with some others. As a result, we have nothing left but to make a whole series of queries. And I would like to point out, not always this data comes with a key by which we can explicitly define the relationship. Okay, that's easy. What do we do next? Run all the queries in a single session. What if there are hundreds of gigabytes of data? I'm not sure that the server RAM can handle it, and dynamic capacity expansion can quickly burn up all the resources. No, we will go the other way. Instead of making several queries once and getting all the information to us, we will perform 100 or even 1,000 small queries to get only some part of it and then save them to the database. You can't just break down queries without knowing what information the field may contain. It's always worth exploring the data first, and don't try to understand everything from the documentation. Download a small sample, look for patterns. For me, I always highlight categorical data and its dependence on continuous data. Highlighting unique patterns will greatly simplify processing later, and you can group a single query so that you only get some unique rows and remove all duplicates. To identify such patterns, I highly recommend performing an exploratory data analysis. It will allow you to identify the structure of the data, isolate allocation layers, which in general may not come up, and understand the correlation and distribution of the data, which will help increase understanding of the data. Remember, knowing your data is the most important thing. Okay, we studied it. We will find relationships. We found what categorical data we can isolate. What next? And then the hardest part is figuring out what to do with the continuous data. Of course, in most integrations and services, we have some key that allows us to define exactly what belongs to what. But in practice, there are much more complex cases. For example, imagine a situation where we have a set of columns and only 4 of them cannot be retrieved together. For instance, in one query, you can include the first 2 columns and in the second, the remaining columns. What you will get in these 2 queries? I wish I could say that on the integration side, when working with the database, we will get the same field with data arrays with the same number of rows. But we don't live in a fairy tale, and we can't hope for that. So what do we do? In fact, for myself, I haven't found the optimal solution for this situation. But here's what I can offer you. I call it cross-checking data dependencies. The idea is simple. If we don't have clear instructions on how to assemble and combine data, we need to come up with a sequence ourselves, and this can only be achieved by trying to find a combination of parameters that will give you a transparent understanding of how the data relate to each other, let's call it data group. What can be the data group? In practice, it's often the case that some set of categorical data is very effective in describing how data relate to each other. This is where understanding the correlation of the data with each other help us. In my practice, in such situations, it is worth checking strongly correlated data. They tell it the most. But what do we do if the correlation didn't work for us? Don't worry, we always have continuous data and I'm pretty sure we'll find the answer in it. This is where my team and I made different queries to the integrations to get different configurations of the data. Of course, we don't do it, but our scripts do, and what doesn't give us. If it turns out that we did different numbers of rows in the basic query variant, then we need to identify the patches on this behavior and find the optimal combinations of query parameters that allows us to get the most refined information. A little tip. If you decide to do something like this, in the first step, only query for raw colors and look for an approach that gives minimal distribution on each. One more interesting example. It happens that record doesn't get into the output if one of the parameters is empty. So, it's worth paying attention to such things. Perhaps the data inconsistency is related to this. Of course, you might ask, Jan, why not try and use of the client name parameter or cabinet name or something similar? And yes, it's a great idea, and it's worth using it to reduce the total amount of data. But in most cases, inside the cabinet or user, all the data is anonymized and will still have to do some kind of relation. Determining the optimal set of parameters for queries, and this doesn't mean that the number of parameters will be the same. There is a high probability that some queries will be from one sample and another from a different sample. Having defined the queries and parameters, it's time to decide what to do about the architecture of the process itself. There are many approaches. It will be a great idea to use Spark, and it will do everything itself. But let's take the hardware and implement everything ourselves. We need several technologies to realize it. Airflow is an orchestrator. It will allow us to both track tasks, schedule them, get stats, and even execute some code, thanks Python and Celery. Databases. Here we need several options at once. Something where we will store our raw data, such as CSV files. An analytic database where processing steps and golden data will be stored. Servers that perform the necessary manipulations. You can also use Airflow if you don't have super complex logic. But I didn't tell you that. So, how do we tie it all together? The best approach, in my opinion, is the pipes and filters architecture. We create a flow from one point to another, and doing the necessary manipulation. What are the stages that our data ultimately goes through? Extraction. We collect data from our sources by querying them according to a chosen plan and collect them into separate files, writing them to our data lake. Initial processing. Each thread is processed and cleaned separately. We build all relationships at the very end. At this stage, we need to perform type checking, replace non-values, perform data normalization. At this stage, we do not talk about cleaning and processing of the data themselves, only their preparation. Now, we write everything already in the analytical database. Processing. The processing itself can be broken down into several stages, each of which will have its own concept. I usually separate the stage of processing textual and numerical information. This allows you to minimize errors, simplify the code itself, and use different tools when doing the job. It is actually very difficult to find balance here. Very many needs will make you code simple on microservices, but the infrastructure will get more and more expensive because we need more servers, more database space, and so on. Very few elbows, on the contrary, will reduce the amount of infrastructure used, but will increase the burden on your employers, forcing them to write everything somewhere in one place, turning your project into a huge monolith. What is next? What is next is going and storing the golden data. Here, using the knowledge gained from the intelligence analysis of our data, you'll be able to understand the data enrichment sequence algorithm and organized great data that will allow your analysts to make the right predictions about the products and services provided by your company. One thing I can say: determine the distribution of the power according to your goals. For myself, I can advise you to perform everything this way. Identify the basic data where it's going the foundation. This is the data that contain the most basic information, the core of your data. We start gluing your data to it and reaching our flow step by step, glue by glue. Attentive viewers may notice that this approach is something similar to the microkernel architecture of an application. Indeed, you can find something similar. We have the core, the fundamental data, and the rounded leaf plugin data that complement the core. And if necessary, we can give only part of the data or all the data or all the fundamental data, providing only what is necessary, avoiding the need for excessive filtering and processing of redundant data. Such approaches, of course, do not always work and not with all data. But thanks to this approach, this can be reduced and the time of data exploration without trying to implement pipelines in full. What to do if the data cannot be glued together or has retrospective updates, we will talk about them next time. Thank you. With you was using some Pynest. Good luck and fun.